Alright, I'm doing a little R&D with my Apple TV X. What I'm doing is I'm using a high-end modified power supply that I'm using as a reference. I'm feeding that down to where I can measure voltage and I can measure current. I can measure the amount of noise on the line. I'm developing that current measurement by going through a 0.1 ohm resistor and measuring the voltage across it. It's actually 170, 190 milliamps. So ignore the decimal, that's in milliamps. Across this resistor, I've hooked the scope up using a 7822 differential input. So what I'm actually looking at here is current. So what I'm looking at is the current waveform. And the bottom is zero current. The higher it goes is the more current that it draws. What's interesting about this is that it's not a DC steady state. Well, what I mean is that I'm going to go a lot faster here, and you'll see that what's really here, what it really does is it draws it in very distinct pulses. You can see those high current pulses. So the real trick to dealing with the Apple TV X, these are the bus boost regulator chips that are drawing more current. When they draw more current, they produce that spiky current draw waveform. What's interesting is that waveform. And that waveform, and that's typically about 1.7 kilohertz, like 2 kilohertz right now. It's up here in the right corner. And that's 200 milliamps per division. So that's a pretty good amount. When those pulses get all the way up to the top there, that's like an amp of high frequency pulses that are being drawn. And that's really the difference, is can the power supply handle that, or does it just sort of blur it all out and not feed it properly? And that's really what that's about. It's about everything that I'm doing is because that's really hard to deal with, to do that properly. So anyway, I found that all very interesting. Very interesting.